All right, let's get it. Another day of daily LeetCode live streams here on this great Sunday, August 14th. This is actually the first day after the 1 month mark that we've been doing this. And again, I'm very happy to report that we have now achieved 162 questions. I'm nearing the 250 subscriber milestone on YouTube, which I'm very happy for, which means I'm only about halfway through to being able to unlock the community feature to be able to interact with you all. And it's just been a good stride. So let's keep it up. Let's keep the momentum going. I hope that for all of you that have been following me since day 0, you're also at a similar sort of spot where I am with the questions that I've solved and the questions that we have solved. And I'm really hoping that if you're not already there, the streams are helping you get there. So without further ado, let's go ahead and get started. We're going to go to algorithms. We'll click the easy ones. Go to acceptance, and I think this is still at, okay, awesome. Let's go to page 2. All right, let's start on this one right here, available captures for Rook. See what is in store for us today. All right, starting off with a so-so quality question, but let's see if we can figure it out. On an 8x8 chessboard, there's exactly one white rook R and some number of white bishops B, black pawns P, and empty squares period. When the rook moves, it chooses one of 4 cardinal directions, north, east, south, or west, then moves in that direction until it chooses to stop, reaches the edge of the board, captures a black pawn, or is blocked by a white bishop. A rook is considered attacking a pawn if the rook can capture the pawn on the rook's turn. The number of available captures for the white rook is the number of pawns that the rook is attacking. Okay, so let's see about this. Return the number of available captures for the white rook. In this example, the rook is attacking all the pawns. Okay, the bishops are blocking the rook from attacking any of the pawns. Bishop, 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 okay. This one, so it's how many, this is a pawn, pawn. The rook is attacking the pawns at position B5. Okay, B5, D7, right? D6, oh wait, is that D6 and F5? So we just want like the nearest ones from wherever we are. One white rook and some number of white bishops. Okay, when the rook moves, it chooses one of 4 cardinal directions. So I think we just want to see if there's any, like how many on the row and the column, those 2 on this column that are within reach. And there's also one, there's a pawn, a pawn, a pawn, and a bishop. So I think the question's asking us like how many pawns are accessible wherever this R is. So what if we just found, okay, I think a good first thing maybe is just to find, can we just like, let me see something. So I also need to know where, I think one thing I want to do just right now in the beginning is get the coordinates of the rook, because we don't have that. Once I have the rook on that column, I can see if there's any pawns, and if there are, I just need to make sure that the pawn is like the closest thing to me. Like if there's a pawn before there's ever a bishop, or it also says what? Stop, reaches the edge of the board, captures a black pawn. Okay. Rook's turn. Rook is attacking. This is 3, 0, 3. Okay. What's like the best way for me to do this? Really the thing that I'm thinking about now is how can I come up with that distance, or how can I, it's not really the distance, but I want to know, okay, like there's 3 pawns here. but how do I know that it's not being blocked by like a bishop or anything like that? Or should I just go in every, should I just go in every direction? We could do that. Let's see. Let's try this out. I mean, it's gonna be like maybe not the best way of doing it, but okay, let's first find the coordinates of the rook. So let's say rook coordinates. We'll just set this to an empty array here. And then we can say for let row equals 0, row less than board dot length, row plus plus. For let column equals 0, column less than board row dot length, column plus plus. Here we say if board at row column is equal to r, then we can say rook coordinates. Actually, let's do rook coordinates dot push. Actually, it'd be nice if we can do, yeah, we can push row and column like this, and then we'll have to have each one of those. And then what I can do is I can break out of here. Then here we can say if rook coordinates dot length is greater than 0, we'll also break out of this loop here. Or I mean, we can also just like right at this moment, right when we get to R, we can actually do the next piece, which is for every single direction, I want to look to find, like let's say I have one rook. How many rooks are, yeah, starting from here, can I get to a rook before I ever get to a bishop? If I do, I add 1, else I just break. So actually I can do this. Let's actually have let captures. We're not even going to store the coordinates. We're just going to do let captures equals 0. We're going to remove this down here. Once we find the R, we're going to look in the up direction. We'll go right. We'll go left. And we'll go, well, I kind of did this down and then left. So we'll do this right here. And then really what I want to do is, I mean, this is not, yeah, this might be like, this is going to be n squared, right, in the worst case. And then here, we're just going to be looking at one section. So if this is, well, I guess we can get to that. We can get to that in the next piece. So up, let's see, for, if I just want to go up, I only want to change the row. So for let row equals, or say for let rook row equals row, rook row greater than or equal to 0, rook row minus minus. So let's kind of do like all these, I'm going to do all these different directions right now. So we'll do rook row, and then if I want to go right, I just want to do the column. So I can say for let rook column equals the column. Here we'll make column less than board of row dot length. And we'll do rook column plus plus. Similarly here to go down, we'll do the same row. This will just be less than board dot length, rook row plus plus. This again will be column, rook column greater than or equal to 0, rook column minus minus. And what we can do is if, so let's see. Here we can say, actually wait, let me move this up here and say if board of rook row and column is equal to B, right? Because we're already considering the edge and we're also considering bishops, right? Because they can be either one of those. It chooses to stop, reaches the edge of the board, captures a black pawn, or is blocked by a white bishop, right? So if it's B, if board rook column equals B, we can just break. And then we can also say if, let's just copy this guy. If board here, if we get to a pawn, we just do captures plus plus and break. This is the up direction. I'm just gonna copy this for all these, right? So now we're just doing at the row that we're at and column, rook column. This will just be row. If it's B, break. If it's P, captures plus plus and break. We'll be at rook row and column, captures plus plus. And then for rook column, we'll just have these as row row, rook column, rook column. So let's just make sure like the row is the thing that's moving, right? So this is starting, this is going up. So until it's greater than or equal to 0, we can keep going up. If it's B, we just break. If it's P, we increase the captures, but also break. Okay, let's see, right. And let me also remove these comments just to clean things up a little bit. So right, we're gonna stay on the same row. We're just gonna go right. So this should be good for that. For this row, we're still gonna be considering the row, but now we're gonna be going upwards, which is down in the down direction. And then similarly for left, row and row column, left, captures plus plus, break. After this, so let's see, if board row equals to R, and there's only one, exactly one white rook. So after doing all this, I feel like we should be able to return captures here. Now, there might be a faster way of doing this, but I want to see what the result this gives us here. Okay, 3 and 3. Let's run the next one. Just going through all my different test cases. Three zero three 303. Let's submit this. Let's see what we get. Going a little bit slow, so it might be time limit exceeded, or it's just not. Well, I guess if it's time limit exceeded, it means that it's not a good. Let me see. So what happened here? Like, I wonder why. Does this mean that there's no? Okay, they're all R's. So why did this exceed the time limit? Let's think about this. For let row, column, 0, board row, row, column, okay. If it's equal to R, which it is, here, okay. For let rook row, row, rook row, minus, minus. Okay. Rook column. Return captures 0. Why did that exceed the time limit? This seems to me just like a normal. This seems like a normal board. Let's go and like. Oh, can we? There's like a note section here, right? Yeah. Right. This is a normal board. There isn't anything. If I've reached the end, why wouldn't it? So it's actually saying that I'm taking too long. Is it worth it for me to even do this? Like, can I keep track of, what if we also keep, what if we keep track of, can we keep track of like ones that we've seen already? That way we only check it if there's also something on that row. Maybe that's like the issue that's happening here. If I like submit this again, are we gonna get lucky? Let's see. I just wish I knew why I was failing here. Less, and greater than. Rook column is, so we're going to start from that column all the way down to 0. Oh, wait a second. No, yeah, rook column greater than 0. Rook column minus, minus. So on the same row, we're just going to be looking at columns, captures plus, plus, and then we break. We're going all the way up, we're going all the way down. So if we started this one, we stay on the same, the row is changing, but the column stays the same. Board, rook, row, and column equals B, break. We go all the way up here. Okay, so nothing happened here, so we just exit out of this for loop. Then we come to this one, rook column equals column, column less than board row dot length, rook column plus plus, same row, we increase column. Here we have the row. We're gonna increase the row, so we're gonna look down, right? And then left, we're gonna be going left. So maybe I shouldn't even bother with this if I haven't even found any on that row. I mean, that is something that we can do. It's not like, I can't say it's like amazing or anything, but let's try and do this. Let's think about this. What if we had let row, we can have something like row P and column P. So here row P stands for row pawns and col P stands for column P's for column pawns. And what we can do is anytime there is a pawn, like if board row column is equal to a pawn, we can say, let's see, if row P of row equals undefined, we can say row P of row is equal to an empty array. We can also say if row C, if col P of column is equal to undefined, we'll say col P of column equals empty array. And then inside of each one of these, row P of row, we can push, I guess we don't, well, there'll be a actually even better way of doing this, but this can at least give us some information. So what I'm doing here is I'm keeping two different data structures to just hold if we've actually seen any pawns on that row or column. So then when we get to here, we only ever count it if there is even one. So if board row is equal to column, or if board row, if we're on a rook, here I want to look on that row. So I should only do this operation, like whether I go down or up. Yeah, we can sort of like, so if row P of row not equal to undefined, right? Because it would only be undefined if we never found anything there to begin with. If it's not equal to undefined, we can actually take the up direction, which will be for that row, and the down direction. All right, we can sort of like group these together. And then we can also say if column P of column not equal to undefined, we can now move both of these. Let me just like expand this to make it a little easier. Not really in love with this solution too much, but so what is it that we're doing here? Like the optimization ways that we made is we're storing in each row or column any single time that we find a rook, we're storing it in these data structures, in these object literals. That way we don't even bother checking a specific row or column unless we know there are some rooks there or there are some pawns there. So let me just like run the test cases again. Okay, 103. So let's see this one now. We actually did worse on this second one. Row and rook row. Okay, column, rook column. Oh, wait a second. Rook column equals column, rook column less than board row dot length. Rook column equals column. Could that have been the issue? Because maybe, actually, yeah, could that have been the issue there? Let me see again. I don't know if I just messed that up now, but now I'm very curious to see if that was actually the problem before. Let me cut this out, move this down here, because you guys saw how I had that expression that was messed up in there. Let's move this out. Let's put these back in here. Let's de-indent these. Let's indent that. Let's comment this out for now. Let's comment this out for now, and let's comment this out for now. All right, so we only want to be changing like, yeah, rook column. But now why would it work? The thing is like, why would it work for Why would it work for these though? Because if I wasn't even incrementing that, let me see. Okay, yeah, so that kind of like, that was the issue there. Now, as you can see, this is a terrible, I mean, 7.57 might be, well, I think I got a 5% before. So let's see if we run it again. What do we got? 15.15, slightly better, but really not what we want. Let's see if we can optimize this a little bit though, right? I don't think I even need to do any of this. I think what I can say is if like for any row and column, there is a pawn, I just want to know that there is one there before I even count it, but there's probably a better way of doing this. Maybe we can do like some graph traversal here actually, and like for every single direction, we just look like all the way to the right. We're either gonna get, like if we get to a bishop, we just return 0. Like the base case is we got to a bishop, or we get to a pawn. If we get to a pawn, we return 1. But if we get to a bishop, we just return 0 and we don't go any further. Now, yeah, that could be a way of doing it. Or maybe this other thing that I was thinking of where we keep track of. So if board row column, if it is a P, oh, but wait a second, like here, right? I need to know. Actually, it doesn't matter, because even if I get there, let me see, is there a case that I can get? Yeah, there might be a case where I get to the rook before I ever see the rest of this. So how would I even know that there's, yeah, I think this was failing because there could be a chance where I get to a rook, but then let's say there's a pawn on the right of it. I never get to that cell at the time that I consider the ones available for capture. So this won't work. So I wonder if like first getting the coordinates of the rook and then doing some traversal would help. Like if I was going, let's see if there's like another example here. Like we come here, this is not a pawn or a bishop, so continue. This is a pawn. Okay, so we just return 1 now. What if it was the other way? Like if I came here, there's 2 base cases. I either return 1 or I return 0. All right, I come over here, it's a bishop, so I return 0. I come up here, return 1. I come over here, return. Yeah, so maybe I kind of want to try that out. That could be like a nice, yo, what's up, Marvin? Good to see you, man. I think we should give that a shot because that could be better. This whole thing right here is kind of weird. So let's like, okay, this is my plan here. See if we can do this. Let's get the coordinates. Get coordinates of the rook. Perform a DFS on the coordinates. Oh, someone just followed and it didn't show the alert. Oh my god, that's so sad. Well, at any rate, Harsadani Chatterjee subscribed. That's amazing. Let me see if like, why doesn't that show there? Oh, that's so sad. YouTube subscribers. How do we? Oh my god. Okay. I'm gonna do something for you. I don't know if Harsadani is watching, but let's make it official and let's put it on the stream. We should be able to see it if I do this. There you go. Am I the only one that sees that, or let me actually see. I know there's like a delay. Oh, there you go. LeetCode live. Oh, that's just me. That's actually a test. It even says that's a test. But at least, yeah, the alert box was hidden behind the live view, so I couldn't even get it to show. But thank you so much for following. That's awesome. All right, so perform a DFS on the coordinates, and then we have our base cases, right? So I'm going to remove all this code because I don't like it. And we're going to find the coordinates. So let's say get rook coordinates. That's going to take a board, right? And what is it going to do? It's going to do for let row equals 0, row less than board dot length, row plus plus, for let column equals 0, column less than board of row dot length, column plus plus, if board of row column is equal to R, we're just going to return the coordinates, row column. Cool. So let's do now, let's say get available captures, get available captures. VP Pat, laugh out loud. I was commenting on Twitch. I don't think he's checking Twitch. VP Pat. Oh wait, when you say that, yeah, I don't check Twitch a lot. Wait, what do you mean that you were commenting on Twitch? I don't think he's checking Twitch. No, I don't check Twitch too much. I probably should though, right? The thing is, like, I have the Streamlabs Prime subscription, so I'm able to do multi-streaming, but I feel like YouTube's my home, and I just end up checking YouTube way more often. So to be completely honest, I'm looking to increase my followers on TikTok so I can go more on TikTok, because I've been putting more content on TikTok, and it's actually been more fun for me. So like, if I'm gonna do any multi-streaming, I feel like it's important that I do it to the places that I really care for. All right, so this one, I wanted to take a board and a row and a column. So here I can say get rook, or let's say rook coordinates. Right, my rook coordinates are gonna be equal to get rook coordinates with the board. And then, let's see, and actually in rook coordinates, I can just do row column, right? I can actually destructure this since I'm returning back an array here. Const row column of get rook coordinates, and we should be able to do return get available captures with the board, row, and column. There you go. Would this be considered a backtracking problem? That's a great question. When I think like backtracking, I think like we're gonna try and make some decision, and if that decision doesn't work, then we backtrack and then we try the next decision, where I feel like this is more of a depth first search, because I'm just gonna like go deep in the right direction, I'm gonna go deep in the bottom direction, left, right, etc. So that's what I'm trying to do. That's what I think. Okay, so what are our base cases, right? We know one of the base cases is like, if at any point, if row is less than 0, or column is less than 0, or row is greater than or equal to board.length, or column is greater than or equal to board of row.length. And let me make this a little bit easier to read here. I just like doing this spacing. Or if we're at a bishop, right? If board of row column is equal to bishop, then we just return here. I'm pretty sure we can just return 0. Return 0. If it doesn't get to this one, then we know we're at a valid location. We can just say if board of row column is equal to a pawn, then we just return 1. Now, could we do return? Let's see, if I just do all of these, get available captures, board, we want to go in all the directions, right? So to go up, we do row -1 column plus board of row column +1 to go right. Here we do board row +1 to go down, and then board row column -1 to go left. Get available captures. Let's see if this works. I'm just gonna go for it. I haven't done one of these in a while. A question like this. Doesn't like what I did here. Get available captures. Oh, wait a second. Is this the same? Oh no. It doesn't like it because maybe I'm like shadowing a variable here. Board. Ooh, maximum call stack exceeded. If row is less than 0, okay. Column is less than 0, or if row greater than or equal to board.length, or if it's equal to board of row.length, or if board row equals b, return 0. What else can happen here though? Why would this exceed the maximum call size? I got the rook coordinates from board. I know it's R. I got row and column, then we do board, row, column. So board, let's say we start here, board of row -1. So if we're here, board of row -1, or I want to do it with one that's like, okay, let's say we get here, board row -1. If board row equals P, we'll return 1. So then we're here. We're going to do right now. We're going to go right. That's okay. Right, right, right. Okay, we come down here. How about left? Maybe left is what's messing up. Column, column, column. That's 0. Then I get over here. Column is less than 0 now. So we should break. Come back here. We go, oh, you know what? Like, are we not? Maybe I need to also check and see, like, if I should probably keep track of like the places I've visited. So I go here, if it's that, here I should say board of row, column. Maybe if I just set this equal to like -1 or something. Or board, row, column equals to -1. Will this work? $11, 0, and 17. Wow. Yeah, like it's hard for me to like draw this out now, right? Because I really want to. It's not like immediately clear to me why something like that would happen. So let me see. We got 0 and then 17. And we're only returning. Oh, but we don't. I don't want to return. I don't want to keep returning 1. Yeah, I think this is going to keep returning 1 every single time, right? Were you LeetCoding consistently before the stream? Yeah, I mean, it's been like a back and forth. I've probably been doing LeetCode now for like a decent couple of months. But the one thing that I haven't done that I'm really hoping this stream will finally get me to is like really, really focusing on medium questions. As far as easy questions go, I've never done this amount of questions on LeetCode, like period. Like 160, whether it's easy or medium, any combination of them. I've never done this many, but yeah, I definitely had some amount of LeetCode practice under my belt before doing the stream. Like it wasn't the first time that I ever did it. Yeah, I think my issue here is like I'm always adding 1 every single time. So it's almost like I only want to add the 1 once. Let's see, if I come here, actually, wait a second. So I'll come here, I'll go right, I'll make that -1. I'll come right, I'll make that -1. I'll come right, I'll make that -1. I'll come here, this is 1. Okay, so then I come here. If board P, I come over here, I just finish this. Oh, but wait a second. If I come back here and I try to do board equals P return 1, set this equal to -1. So I come over here, I come back here. Oh, and now I'm going all the way down. Oh yeah, that's too much. Yeah, this is actually probably not what I want because I'm going all the way right, then come back here, then all the way down. But really I always want to do it from this first piece here. I guess it would almost be like very similar to what we did earlier where I would just check on either direction, right, bottom, left, down, right, bottom, left, up. Yeah, I think I have an idea of what to do, but since we've only done a single question, I think I might just skip this one. Maybe we'll come back to this one during a weekly roundup, or maybe even like tomorrow or something, because I think I know what to do here. I think we can do the same thing we did before. We can still do it recursively. Yeah, maybe we can try for like 5 minutes. Get available captures. Makes sense. I'm going through Grok in the coding interview, and most of questions are medium, and it's a tough grind. Yeah, the mediums are really where you get the most value. So once you start doing those, I feel like you're truly leveling up. This is mostly like me doing the easy questions is proof of concept. Can I actually do all of them? Can I get the channel growing? Can I make a habit of doing it. I think the channel will really become a thing when we get to mediums, because that's where you learn the most. That's where we're really gonna have to learn how to be creative and understand these answers. I wish there was a way that we can just keep without me having to make like many different functions. Yeah, I'll skip this one for now so we can just get to the next one. 2 furthest houses with different colors. Oh man, for some reason I see this and I'm thinking already dynamic programming, but we'll see. There are n houses evenly lined up on the street, and each house is beautifully painted. You're given a 0 index integer array colors of length n, where colors I represents the color of the ith house. Return the maximum distance between 2 houses with different colors. Oh, okay. Maybe not. So we just want to find. I feel like this could be a 2-pointer question. It could be. 1 and 3, those are both different. That's 1 and 1. Which one do I move closer? How do I know to move the right or the left one closer? Well, if it's 1 or 6, or if they're both the same, we can move both of them inwards. Could we also do like a mapping? Like if I sorted these will all be 1, 1, 1, 6, 1, 1, 1. Could we have like LeetCode streams? You're good at explaining stuff. It's up to your preference, but you should try to stream on Twitch. There's a good community of people that are interested in LeetCode streams. You're good at explaining stuff. Oh, awesome. Yeah, thanks a lot. Like I really appreciate that compliment. Yeah, like I guess I'm sort of doing that by doing the multi-stream. I hope that people are seeing it on Twitch and they can get some value out of it. Do you have any tips for like me trying to expand my reach on Twitch? Or I know my profile on Twitch is very minimal. It's certainly not like as decked out as like on my YouTube channel. I definitely have things a little more polished, if you will. Again, I just started on YouTube, so I was like really happy to get on YouTube and just like really focus on that. But yeah, I'd love to hear like more feedback that you have. 2 houses have different colors. So I know I like think about 2 pointers here, but I'm also thinking about sorting it. Because then we just have to find, like if I had something like this, like these are the houses here. And then what if we had 1, 3, 3, 8, 8? Maybe I just store the last, or I can store the first index of 1 and the last index of 8. The furthest 2 houses with different colors, right? Because that's the one that I want to find. And then, but it wouldn't be, but it needs to be, okay, these are actually in order here. So it can't be that. I mean, there's definitely a way to do this brute force, right? We just do an n-squared algorithm. Every time we find 2 different numbers, we calculate the distance, and then we continue doing that till we find the maximum one. But how else could we? This is it's similar to there's like a lot of questions that are like this. I don't know what the pattern is exactly, but I guess finding like the range of different points. I have a 1 and a 6, a 1, 8, 3, 8, 3, a 0 and a 1. If I just have this first one here, one, 1, 1, 6, 1, 1, 1. If I want to find the distance between, and this is a good question, so we should focus on this one for a while. Let's see if we can do it. Even if it takes like the rest of the time, I'll be really happy if we can figure this out. Like, what if I had coordinates of all the different ones? Or what if I knew where all the ones were, which I do, but what if I had a table that told me where the furthest one is. So when I get to a 6, color 1 is blue, color 6 is red. The furthest two houses with different colors. It's almost like if we're given, I mean, it's the same as like if we're given an array with all these different numbers, find the two numbers in the array. Well, no, it wouldn't be that, right? Because I was going to say find the numbers in the array that are the furthest apart, but then we could just sort that, and the distance would be the last one minus the first one. So this is all positional. 6 and a 1, all these are different, so it'll be this one or that one. And here, like multiple ones of these are different. Like, oh, it can be this one because these are both different. This is one distance. It can be this one. It can be that one. It can be this one. How do we? I guess like, could we do? What if we did a two-pointer, like a sliding window type of thing, where we had like a start and an end, and I can say like, okay, increase the end if it's different. Like here it's the same, so we increase start. Here it's the same, so we increase start. Or maybe we should do, okay, like start now is different, so we increase E. It's not the same as 6, so I can increase E. So wait, can I increase? What if we do like increase? My tabs are all messed up here. Increased end while not the same as S. Right, like increase end while it's not the same as S. So I'm gonna start here. And I'll say, well, no, these are both the same, so I'll increase the start. Increase the end again. It's the same as 1, so do this. Okay. Increase the end. It's different than 6. Okay, so we can keep going. Now it's the same. So increase start. It's different than 6. It's different than 6. It's different than 6. I think something like this could work. Because if we get here, okay, that was that one, right? Let's do this one down here. Which I realized we already had up there, but that's fine. So we can just start end after S. Like, is 8 different than 1? Yes, it is. Is 3 different than 1? Yes, it is. Is 8 different than 1? Yes, it is. Is 3 different than 1? Yes, it is. Okay, cool. Sounds promising so far. 0 and 1. So yeah, I think this could work. It looks like sliding window. Yeah. I hope that like what I just drew kind of makes sense. Give me a second. Let me like put my AC on because I'm really hot. I'm gonna put like the screen up, so I'll be right back in like a second. All right, we're back. Okay, cool. So let's give this a shot. Let's do like some sort of sliding window here. So I'm gonna do let's start equals 0. Let end equals start plus 1. I think I could say while end is less than colors dot length. So increase end while not the same. So like in this case here, 0 and 1. I have start and I have end. So if end, let's see, if end, and let's also do max. Let max distance, we're gonna make it a small number, negative infinity. So if colors of end is not equal to colors of start, and we can say max distance equals math.max of max distance or end minus start. And then we can do n++. Store the distance. Right, yeah, that's what I'm trying to do here. So let's see what this gives us, like store.end, n++, we'll get to the next one. right? So then we'll get 1. So we know it'll work for that first one, but that's a trivial example. So let's get to this next one here. Let me just remove all this. We're gonna do start and end. Okay. So if colors end is not equal to color start, okay, not equal to color start, not equal to color start, not equal to color start. Okay, the next one, cool. That's gonna work for that one. Let's get to this one now. Let's reset up to here. Okay, so if colors end equals to color start, so else if they're the same, we should make start equal to end and end equals start plus 1. So if they are the same, and I guess the max distance will just be 0. That's probably a good thing here. So start is this, and then end equals that. End is still less than colors.length. They're the same, so start equals end equals that. They're not the same, so calculate the distance. We increase this. They are the same, so should start equal end? No, I think start should just equal start plus 1. I'll say this, start equals start plus 1. End equals start plus 1. Okay. Now we're here. If colors end, okay, they're not equal, they're not equal, they're not equal. So we'll keep doing this, and then we'll eventually go to the end. Cool, so I feel decent about this. Let's see what our test cases give us. Oh, look at that. I don't think I even returned anything. That's a classic mistake. Classic mistake. Okay, 341, 341. Let's submit this. 9998. Oh, expected 9. Okay, let's figure out this one here. So we have start and end. We're going to start at end equals start plus 1. So these are the same. So start plus 1 and end equals start plus 1. These are the same. So start plus 1 and equals this one. Okay, these are not the same, right? Wait, so how is this 9? Very curious already. Like, oh, 9 and 18, right? Wait a second, how did it work for 9 and 18 and then 1? Oh, because that one, and then 1, 1, 1, then we get to 6, that becomes the, oh man, okay. Why would I not, like, why would I keep going? This is interesting, the max distance, 999, 18. Like, why would I, if it's the same, do I just try and keep going? That doesn't sound right. I almost thought it might be like a sliding window type of thing, but now why wouldn't I increase the value of any of these? Like, why would I keep end going all the way up to here? Maybe it's actually like a 2-pointer. You know what? It might be 2-pointer where we start, let's say it's 2-pointer like this, where I start on either side. So right now already these are both different, right? Because the maximum difference will be the one on the ends. So, but now the question is, how do I know which one to decrease? Like, do I increase start or do I increase end? Like, let's say in this example here. Well, in this example, do I just try both sides? Do I try and see if I can find the first one? Let's see, 0, 1. These are, none of these examples are great. Like, what if I had an 18 here and a 9 here? Like, these are both the same, right? So like, which one do I decrease? Like, why would I decrease E? It will be the last house with different color from first house. First house. Notice how every example, the ith house is always the first house. Notice in every example, the ith house is always the first house. I'm not sure what you mean by that one. Color 1 is blue and color 6 is red. If that houses 3 and 6 can also produce the optimal answer. It will be the last house with a different color from the first house. Notice how every example, the ith house is always the first house. Oh, I see. Well, do you mean... I think I see what you're saying. Like, what's the first time... Oh, wait a second. What's the first time... 3, 3, 3, 8... 3, 3, 3, 3... 3, 8, 3, 3... What's like the last time, or if I have a 1 here and I start from the end, okay. What's the first time? If I go here, what's the first time it goes? It can be this one. Or, well, I mean, that might be, but then I almost think I know what you're saying, and now I'm thinking of this another way, like, it's just a matter of knowing what number after this one, like, this is 1 and this is 1. This is 3. So this is what I know is 0, 1. Why do I feel like I've done a question like this before? Oh, here we go. 0, 3, 0, 4, 0, 1. The first house is always the 0th index. So they're saying like, but is that really, they just want me to find the first one that's different than is that really what it is? Wait. For let I equals colors dot length minus 1, I greater than or equal to 0, I minus minus. If colors of I not equal to colors of 0, return I, return 0. 3, 4, 1, 3, 4, 1. Wait. Well, okay, we know this one's gonna return the right one. But is that really it? Oh, okay, no. I don't know if that was, is this what you were talking about, VP Pat? I'm curious. I was like, man, that would be something else if that's what it was. 81 out of 126 test cases passed. 4, 4, 4, 4, 4, 11. Six expected 8, because the 11 to 4 is the best one, not this 11 to 4. It's actually this one. So what happens if we, should I just consider both sides? Like, do I consider this one, and then, like, what if I did the same thing on both ends? No, it's okay, man. I mean, I think that's probably better than what we had in the beginning. I don't remember like how many test cases we passed here. Let me see. Yeah, so I mean, that was much better than my sliding window solution. I wonder if it's like, what if we did this? What if we actually did this twice? Let's do let max distance. Let's say let max is equal to 0. Here we'll say max equals math.max of max or I. Or here we can start at 0. I less than colors.length. I plus plus. If colors of I not equal to colors at 0, we just return I. We'll do the same thing here. Dope-tastic. I don't know if that will change anything though. 3419, 3419. Oh, what's the one from before? Oh, we lost the other one. Well, we know the other one was right anyway. So still, oh really? Because shouldn't this be, it's gonna try to do it from here. Oh, wait a second though. This is trying to do from here downwards. Yeah, no, I should do it starting from, wait, I equals colors on length, I greater than 0. I should be counting upwards. Yeah. Upwards this way and then downwards this way to whenever it's the first time that it's, yeah, this is not how it should be. So I plus plus, if colors of I is not equal to colors of colors dot length minus 1. So starting this way, so like we get to here, right? So what will this be? This will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But 11 minus 3 is not 9, that's 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I don't actually want to do, because the answer, oh no, the answer here is 8. Okay. So we can say the max of colors dot length minus I. Okay. So that's going from 0 all the way and comparing it with this last one. Now I want to go from colors dot length, and if I go all the way down, if colors I is not equal to colors of 0 here, then we just return max of I. So let's try this one out. Okay, this should be this one. 4, 5, 2, 9. So wait, well, we're all 4, 5. Yeah, wait, we're all off by like 1. So I'm probably missing something here. Maybe this should be minus 1. 3, 4, 1, 8. So should we try this out? But this is assuming that we're only ever comparing it to the last one though. That's the one thing I don't like about this, because it doesn't need to be the one on the bounds, right? It could be the ones in the middle. But let's submit it anyway. What? Okay, I was not expecting that, to be honest. This is like so surprising. How is that? Okay, so this is assuming though that like it's gonna be, so VP Pat, your suggestion was like, you're pretty close. I mean, we're only considering the bounds, but why am I only ever taking the last one? Like, why can't it be? Maybe what we should have noticed, maybe instead, is I think maybe what you meant, VP, is that the answer always includes the one on the bounds. So it's either going to be the furthest from the left or the furthest from the right. Maybe that's like a way of thinking about it. Let me see what discussions say. O of n solution. The first and the last house can be one of the furthest houses. Find the last house with different color of the first house. Find the first house with different color of the last house. Oh, nice. So this is the two-pointer technique, I guess, right? Because we want to increase, yeah, we want to decrease J. Return the max. Okay, find the last house with different color of the first house, and then return the max of each one of those, which I think is what we're doing here. That's pretty much what we're doing. Okay, that's a strange question. I'm gonna add this to my list. Increase this here. So by the way, I'm going to make a video about this once this stream is done, but I've been working on my site here. So some of you may have already been using rafaelslist.com. One thing that I just added support for, as you can see, is being able to mark questions that you've completed. Now, currently this only exists on local storage, so it will only persist on the same machine that you're on, probably sometime in the future. And when I say future, I mean very near future. You'll be able to actually come in here and you can persist this logic across like any machine that you're on. Yeah, 69, right? That's funny. I didn't even notice that. So, and I wonder actually if this like search and binary tree. Yeah, so I think there's there's one more change I want to make to this to make it a little more responsive on mobile devices, which I'll do after this stream. And I'm going to make a separate video on this so I can like introduce version 2 of the website. But just letting you all know, rafaelslist.com, I put the link on every single stream that I do. It's a list of top quality questions I've compiled throughout my journey of doing every single LeetCode question. And I think one of the cool things about it is not only do you get to see the top quality questions, the most important thing is you can go directly to the stream where I solve that question. And I think that's really where the value comes. The reason I did this is because, you know, I realized that I'm making all these streams, but if you want to wait to like replay the stream or remember what it was that I was talking about, it was kind of like hard. So I just created this website to do that. But again, yeah, 431 more to go. Of easy's, the hill's getting smaller. It is absolutely getting smaller, which is insane. I mean, we started like, I think it's like 580 and now we've completed 160, and that was in 1 month, right? So probably if we're averaging 160 a month, you know, like in 3 months time we'll be done with all the easies and we get into the mediums. So if you're here and you haven't already, make sure to subscribe to my YouTube channel or follow me on Twitch. It's going to help me continue doing this and continue evolving this website and putting out more streams so you guys can always see the stuff that we're working on. Let's like do one more because I feel like we only did 2 questions here, and I really want to make sure, I really want to maybe do one more just to make the stream like well worth it. Although I realize it's getting a little bit late here, so, and I normally don't like to keep the stream too long, more than an hour, but let's see what this one says here. So we're given 2 integers x and y, which represent your current location on our Cartesian grid. You are also given an array of points where each point I of ai, bi represents that a point A exists. A point is valid if it shares the same x coordinate or the same y coordinate as your location. Return the 0 index of the valid point with the smallest Manhattan distance from your current location. If there are multiple, return the valid point with the smallest index. Okay, so x, 3, and 4. Of all the points, only 3, 1, and 2, 4, and 4, 4 are valid. Of the valid points, 2, 4, and 4, 4 have the smallest Manhattan distance from your current location with a distance of 1. 2, 4 has the smallest index. Okay, so I feel like just by the nature of this, when it says it's valid, how is it not valid? What's a valid distance? Oh, a point is valid if it shares the same x coordinate or the same y coordinate as your location. Okay, so can we do something like, do I just want to return the first one? There are no valid points. Okay, one thing that we could do, I think that we can do here, is we can say sorted points will equal, let's see, we'll do points dot sort. I'm going to put this on its own line. Here we'll say point 1, point 2. Actually, let's do this. Point 1, point 2. So we want to return what? I want to return it in increasing order of like x. I think that'll be fine. So we can do point 1 of 0 minus point 2 of 0. And let's make sure we remove the curly brace. So that way we just get like the implicit return here. Can remove all this and just add this. So sorted points. Oh wow, that was a lot of extra space there. So out of these, smallest index, so return 2. I guess we can say, I don't know, why is it starting me so far? Oh, wait a second. This needs to actually, yeah, no, wait, this does need to close. Here we go. Right, that looks right to me. Okay, so let's say const min distance is infinity. Let's do that, and then let's also, that Manhattan distance is what? Between 2 points is ABS of, okay, so I can say const calculate distance. Here we'll take an x2 and a y2, and we're going to return math.abs of, let's see, x1 minus x2. So x minus x2 plus math.abs of y minus y2. Right? That's what it is, the absolute value of that. Okay, so that's the distance. And now let's see, of all the points, can we just calculate for each one of these points for const point? Or maybe here I can say x1 y1 of, for const x1 y1 of points, I can say if calculate distance, I always want the smallest one, right? Output 2. Okay, if calculate distance of, let me see, x1 y1, even though I realize I should call this x2 y2 so I can match the names of the arguments or the parameters. X1 y2, so if calculate distance here is less than the min distance, you can say min distance equals this. I guess we'll do it again, probably an optimization I can make there, but then I should also say nearest point, I'll set this equal to null, but then I'll also return nearest point equals, could I just set this equal to x2, y2? Return nearest point. Does this work? Min distance, let's see. Oh, const. And yeah, we should make, let me like read this again. So I have sorted points here. So I'm sorting these, I'm getting the min distance and the nearest point, then I have my function to calculate the distance, which is just this right here. I'm going through each one of the different points. And maybe what I'll do here is I'm actually, well, let me see if that works first. I'm gonna calculate the distance. If that's less than my minimum distance, I'll update my minimum distance, and I'll also set the nearest point to be the one that we just used to calculate that minimum distance. And because it's sorted, which we have to go to sorted, I'm sorting it because in the case that there's two of them, right, like 2, 4, and 4, 4, we return the one with the smaller index, which is 2, 4. And that's what the sorting is going to help us out with. Okay, we have nan, return nearest point. Is that because, and this is not even nearest point expected to, oh wait, it doesn't want, okay. So should I just return min distance? One and 2, okay. Wait a second, I'm not taking into account that it has to be, yeah. Okay. So forget nearest point, because we don't need nearest point, right? We just need min distance. So here we can say if it shares one of the, yeah, if x2 equals x or y2 equals y, which is these ones. So as long as one of these are the same, we can say that min distance, yeah, let me remove all this, copy this right here. Here I'll say min distance equals math.min of min distance or calculate distance of x2, y2. Let's do this here. Infinity. If there are no valid points, return -1. So here, what is it that I want to do at the end though? Min distance. Maybe instead of setting this to, what's the highest that my numbers can be here? Points I.lay is less than or equal to 10 to the power of 4. So 10,000. Min distance is 10,001. So anything lower than that. And if we never found one, does that mean that there aren't any that are less? How do we know if there, oh, if there are multiple, oh no, wait, if there are no valid points, that valid points equals false. This is kind of like a hacky way of doing this. Valid points equals true, return valid points. We'll just return min distance, else -1. See what this does. Still 1 and 2, even though we're considering, is it this thing that's like acting up? Point 1, point 2, we have our points dot sort. Okay, calculate distance, math.abs of is x1 minus x2. So here we have the x, and then we have the x2 that we're passing in, plus abs of y1, which is y, minus y2. Okay. Let me, instead of doing this right here, I'm going to do for const point of sorted points. Here I can say point 0, point 1. And it's saying that it's valid if it shares the same x coordinate or the same y coordinate. If point 0 is equal to x or point 1 is equal to y, we can go ahead and calculate the min distance, which will be the min distance or calculate distance of where we are currently, point 0 or point 1. And then we'll set valid points equal to true, or we can return min distance. Still 1 and 2. Why are we getting 1 and 2 here? So in this case, none of them share it. So valid points will just be false. So we return -1, okay. Actually, let me see for the other test cases, what is it that we're getting? Do I even need to 1, 0, -1? Like, what happens if we don't sort it? Oh, but that's the thing that's helping us get to how's the system design studying going? You mentioned it on Discord a while back. Yeah, honestly, I haven't been doing too much system design stuff because I'm very like involved in this right now, the LeetCode stuff and the YouTube stuff, and it's been like, it's sort of like I'm very passionate about this right now, so I just haven't found a lot of time to do system design stuff. But at some point in the future, and this is like way into the future, I would like to start streaming. I would like to start doing the same thing I'm doing for LeetCode for system design on the same channel. I don't know if that'll be like a rebrand of the channel or however, you know, like maybe instead of calling it like LeetCode Live, it'll be like System Design Live. Maybe I'll like rebrand the channel and call it just like Live Coding or something like this. But I hope to be able to do that at some point too. Okay. 1, 0, -1. Of all the points, only 3, 1, 2, 4, and 4, 4 are valid. Of the valid points, 2, 4, and 4, 4 have the smallest Manhattan distance from your current location with a distance of 1. Oh, wait a second. Okay, what do you mean the index though? Like, oh, with the smaller of the indexes. Okay, so I am getting, okay, I see, okay. So we found the min distance. I should probably also save, yeah, okay. Let's do let coordinate. But then how do we know that we have more than one? Should I just get all of them of the valid points 2, 4, and 4, 4? Answer is allowed to be on the same location as your current location. Okay. There are no valid, so if there's more than one, because like I can just find one, and that will just be the distance. Now if there's more than one, yeah, I think here, maybe we should, oh, you know what? The Manhattan length. It'd be cool if I can almost do like a bucket sort, or like create some sorted array. Yeah, because this is size of 10,000. And each points at length points I dot length xy ai bi is less than or equal to 10,000. That would be like really long. I think maybe like we can save the coordinate, and anytime we find, yeah, I don't think I actually need the sorted points here. I think we can do this. Like, there's gonna be a couple of edge cases. There's gonna be a couple of cases here. One is no valid points, right? No valid points. One valid point, multiple points. So what if I actually created, I'm gonna like remove all this. I'm gonna do something crazy and just delete all this. I'm sure you guys have done that before in your projects. You just like nuke everything. But let's actually do this, right? So what if I instead have a distance map here, like distances is equal to this. I have distances. I also have let min distance is infinity. So let's go through this. Like for const point of points, this is going to be x2, y2 equals point. So if x2 is equal to x or y2 is equal to y, we'll just go ahead and do like an inline const distance is equal to math.abs. And what is it again? It's x1 minus x2. So x minus x2 plus math.abs of y minus y2. Okay, so what is it that we want to see? Let's go ahead and like we have the new distance right now. Is that going to be less than any of my other distances? But it also might be equal, right? So what if we say if min distance, or if distance is less than or equal to min distance. I'm trying to see how I can use this map to help me out here. Because like 2 and 4 here, right, we're getting that both are the same. So I could store inside of 2 and 4, inside of this distance, I can say like distances at distance is equal to the current point that I'm on, x2, y2. And the min distance will equal distance. Okay. So let's say we get, it says of all the points only 3, 1, 2, 4, and 4, 4. 3, 1, 2, 4, and 4, 4. So we get to 3, 1. That's going to have some distance. It's less than the min distance. Okay. But then 2, 4 is even less. And that's going to give us some new number, presumably. Now 2, 4 here. If it's less than or equal to min distance, maybe, oh, this is where the sorting would have come in place. Because then I can say if it's less, like 4, 4 would probably still give me a 1, right? That wouldn't be less than 1. So the min distance will still be 1. And inside of distances at 1, we'll have this one. So I think we can just return whatever is here. Now, if we only ever have 1, only if there's 2 of the same, that's the piece that I'm like a little bit confused about. What's a good way to figure that out? Two, 4 has the smallest index. Oh, is it the index? Oh man. Okay. Even before this, it's actually the index of where it is in the array. Return 2, return 1. What if I just break as soon as I find? I mean, if it's never... but only because there's one. Okay. Find if we are storing the smallest distance, store the smallest distance and the location where we found it. If there's more than one, we just store where it is. I can't put this in code right now. But we're so close. I think I'm gonna do this since we're like pretty over the time. I realized this one was a little bit of a slower stream. And not to make any excuses or anything, but it's been a very slow day here. I went last night to a concert, so it's just been like a recovery day. You guys have probably seen, like, I think 2 days ago we did like a very 2 days ago or yesterday we did like a very, very good stream. We did like 5 different questions. Today was just like a little bit slower. But this is what I'm gonna do. I'm gonna end the stream here at 1 hour and 20. You have to imagine that, like, if we're going through a journey of every single LeetCode questions, of course there's gonna be some that are better than others, but I'm gonna end it here today. And what we'll do is I'll think about some of these that we tried. Like, I'm gonna think about the available captures for Rook, and I'm also gonna think about this nearest point one, and we'll revisit them again tomorrow, and we'll make the one tomorrow probably like 1.5 hours to sort of recoup on lost time. And that way we can just like stay right up to date with everything. What I'm also gonna do is right after this, I'm gonna be making another video sort of like introducing the new site and showing you all how you might be able to use it for your studies. And you can just help yourself keep track of things that you've already done. I think people are like really looking forward to that. So with that being said, really happy that we actually had like way more people watching today than I think we've had in the past. We got up to like 6 viewers. So that was very, very cool. So thanks again for everyone that was watching. I'm going to go ahead and, edit this stream and put it up on the YouTube. Thanks to everyone on Twitch. Thanks for the advice you gave me earlier and the feedback, VP Pat. Really appreciate that. And we'll start off tomorrow strong. Strong Monday is always good. And let's just go and get it. So I hope you guys have a great rest of your weekend. Enjoy the last day. Enjoy the Sunday. And we'll see you all again tomorrow.